Welcome back to the studio. Today, we're tearing down this piece of hardware on the table. It's a prototype designed to solve one of the most frustrating bottlenecks in field logistics and mobile video capture. If you look at traditional body cameras or smartphone chest mounts, they all rely on the same flawed architecture. Heavy, militaristic harnesses wrapped in clunky nylon straps and plastic buckles. That creates a massive human behavior problem. Whether you're a delivery driver hauling heavy packages or a creator shooting on the go, friction kills adoption. If gear takes more than 2 seconds to put on, people will actively avoid wearing it. We built this prototype around a design philosophy we call SanGear. The objective is to eliminate every single strap, buckle, and harness to achieve absolute zero friction adoption. Because at the end of the day, hardware only survives real-world conditions when it becomes completely invisible to the user's daily workflow. Here is the raw, assembled device housing from the front. What you see is a sleek, low-profile black neoprene sleeve. It looks like a standard, minimalist phone pouch, but the actual mechanical advantage is hidden on the back. The rear assembly plate features a specialized 3-point triangular layout. Integrated directly into those gray mounting brackets are high-flux N52 neodymium magnets. This creates a magnetic sandwich mechanic. An inner anchor plate slides behind your shirt or jacket, and the outer pouch snaps instantly onto the outside. It tightly compresses the layer of fabric between the plates. We extended that magnetic footprint specifically to distribute the physical torque. When a user is walking briskly or climbing stairs, that wide stance aggressively arrests side-to-side twisting, keeping the camera lens perfectly stable. Moving to the sides of the pouch, we engineered a specific tension sleeve architecture. Instead of relying on traditional accordion folds that can wear out or absorb moisture, the sidewalls use injection-molded TPE or TPU elastic gussets. This allows the sleeve to stretch and automatically conform to any size smartphone or rugged case. We also removed the top cover completely to create a flapless entry. A user drops their phone straight down into the pocket instantly, without fumbling to rip open zippers or snap buttons. By combining heavy-duty magnetic compression with modern elastomers, the device delivers the structural stability of tactical body cams, all wrapped in an everyday consumer form factor. That specific combination of speed and stability translates directly to the multi-million-dollar corporate logistics sector. Take the highly specialized field of non-emergency medical transportation, or NEMT. In NEMT, drivers operate in a high-risk window known as the last foot. This is the physical transit of a vulnerable patient out of a transport vehicle, across varied, unpredictable outdoor terrain, and directly into their home. During that brief transition, service providers face severe financial exposure. Unmonitored slips, trips, and falls on private, unmaintained walkways lead directly to massive legal liability claims. Traditional fleet software and GPS routing are completely blind here. Once the driver leaves the van, there is zero digital documentation of the ground-level physical conditions. The only way to secure a verifiable audio-visual audit trail and protect companies against those specific claims is to deploy a wearable physical hardware solution directly on the operator. But standard off-the-shelf action mounts fail in this environment due to a geometric flaw we call the horizon-overshoot. Let's look at the anatomical geometry. When you attach a traditional mount high up on the flat upper chest, the camera array sits on a highly vertical plane. This forces the lens to project a straight line of sight out toward the horizon. It completely overshoots the immediate walkway, missing the operator's hands and the ground terrain entirely. We resolved this by engineering an anatomical hack. By dropping the mounting apparatus down to the lower abdomen, the geometry shifts. The natural outward curve of the human lower torso near the stomach establishes a fixed downward mechanical tilt. It achieves the perfect angle automatically, without requiring any complex plastic hinges to adjust. That downward orientation perfectly frames the critical action zone, the package being carried, the steps, and the immediate surroundings during a patient transfer. Lowering the camera placement just a few inches leverages human anatomy to capture the definitive visual evidence required to win liability claims. Documenting this process, the raw, unpolished journey of building a hardware startup from scratch, is exactly why we started this channel. We moved rapidly from early desktop iterations to printing structural components, allowing us to get the device outside and test the physics in varied environments. We locked the magnetic chassis onto this metal mesh patio chair to test the brute strength of the compression plates. It held firmly. You can see the permanently open camera aperture design on the pouch. It leaves the phone's native lenses completely unobstructed, so they can record with total optical clarity without shooting through cheap, blurry plastic layers. We also secured the system to a public railing. This demonstrates that the magnetic chassis functions as a versatile stationary mount, in addition to its primary role as a wearable. That multi-use versatility means the exact same pouch functions seamlessly as a temporary dashcam, a stationary tripod for creators, or a highly stable wearable body cam. This initial Frankenstein prototype phase successfully validated both the structural physics and the cross-industry utility of our patent-pending design. Right now, the core utility patent for this strapless, open-aperture chassis is officially pending. Our next major engineering hurdle is finalizing the injection molding schematics. We are moving toward unified assembly for mass production. But transitioning from a 3D printed prototype to custom commercial manufacturing requires significant upfront capital. That is why we are shifting to a community-backed model. Make sure to subscribe and join the launch. We need your support to back the upcoming crowdfunding campaign and bring this into production. Before the official campaign link goes live, we will be dropping several raw field testing videos right here on the channel to show you exactly how hard we're pushing this hardware. We are out to lose the clunky gear and streamline hands-free recording for everyone. Thanks for watching, and we'll see you in the field.